Thank you very much, Theo. So yeah, I'm going to talk to you primarily about cell-based meat and precision fermentation. And I'll give you a hint from the start. The technologies actually work because we've been using them for decades in the pharmaceutical industry. So as you'll see, the rest of it, it's not that they don't work. It's about scale. It's about consumer acceptance. I'll go through and I'll unpick some of those issues. But the first thing, and it's generally in, when you're talking with startup technologies, it's whether the tech will work. This tech works, but that's not their biggest challenge. So I'll just set the scene a bit. No, that's not working either. That worked. All right. Okay. So I think we just need to set the context, and this has come up because if we're looking at any new tech, what's the solution we're trying to actually solve? And the solution we're trying to solve, and a lot of these groups will stand up, is to feed the population of 10 billion people that we're going to have. But this shows you where they are. They're not in New York, they're not in Dublin, in London, in Sydney. They're largely all in Africa. So as we go through this presentation, ask yourself, is this the tech that's going to solve the situation of Africa? Because that's actually the problem. This issue was also touched on yesterday. We've got this quite divergent sort of challenge. We've got this severe undernourished group of people, and Shirley's told you about that today, and we've heard some of that tomorrow. But then we've also got 2 billion people who are obese. Whatever we do can't make this situation worse. It's got to actually make this situation better. So it's got to be good nutrition, and it's got to be equitably distributed. I've also thrown up a bit of an ad for Jack Bobo's book, because if you want to know why we make really stupid choices about food, it's not because we don't know. Jack will tell you why. And it's really, so if you're interested in the food, it's a fun book to actually understand. It's not an education issue. We actually often know what's good food. We just make bad choices. All right. So let's just, where do these two technologies fit? So they fit into the alternative, or Michelle Colgrave's here, she calls complementary. So these it doesn't have to be one or the other. These are all going to be ways of providing protein or nutrition. I just put up some of there. The plant-based is the one that probably everyone's pretty familiar with, but there's also plant-based dairy. About 15% of the market in the US now is plant-based in dairy. But there's fungi. Quorum's been around since 1985. So some of this technology has been around for a long time. There's algae, there's insects. Again, Theo mentioned I'm on the board of an insect company. Soldier flies, you're actually dealing with the waste streams, and you can turn it into protein. You can feed it to humans. We largely make pet treats out of it, but it's actually a really good source. But I'm going to focus on cell-based meat. I put up some of the companies there, and precision fermentation. When I was a young student, it's a while back now, we used to call it recombinant protein production, but that wasn't sexy enough, so it's now called precision fermentation. There's over 1,300 startups. So this is a field that's blown up really quickly. We're talking about billions of dollars that is continually being invested in this space. So about 1,300 companies. Interestingly, when you get into the ownership of that, it's largely the same companies sitting behind there. So the big food companies are making sure that they have a bet either way. They don't really mind what food you buy, as long as you buy it from them. So not too surprising that we're not actually moving away from that concentration of ownership. Some people like to say JBS is investing, they're clearly going to get out of meat and they're going to go all into alternative or complementary. They just closed their plant-based factory in the US, so probably not. But it's it's an interesting what people interpret from some of these investments. So what are some of the major issues for the alternative protein market? So matching taste and texture is a really big one. What we do know is people, particularly in the affluent societies, won't give up taste and texture. the mouthful when you have a glass of milk, the bite when you bite into a steak. Nutritional profiles, we've talked a lot about that. A lot of this tech is relatively new, and we still don't actually know if the nutritional profiles are the same. I went in front of the Senate inquiry in Australia on labelling. This was a big argument about what should be on the front of the label. I was with Rod. It was about whether you should have milk or meat on the front. And our argument wasn't the label, the lie wasn't on the front of the label, it was on the back. Because on the back, it said this product has the same nutritional characteristics of milk or meat. But it's actually not true, because it didn't take into account bioavailability, didn't take into account quality protein. Nick's told you all about these. So the lie is actually on the back of the label. It's not on the front. So and the growth of the market was also stagnated. So they were off on, they had fantastic growth, but in the last year or so, particularly in the US, it's really flattened. And that started to scare the markets because a lot of venture capital money came into this. We've seen two of the big companies, Beyond, you've heard, I think someone showed a picture of Beyond and Oatly, the oat milk company. Both of those companies in the last year lost $10 billion of their market value. It started to scare the market a little bit about what's going on. And you're actually seeing articles coming out. Is this the death of it? It's not the death, it's just what markets go through. But it doesn't encourage new investment necessarily when you look at the sort of nature. The venture capital market has come into food. They think, you know, we're in biotechnology, in pharmaceuticals, we'll make a killing in food. They didn't probably understand the food industry, and they didn't understand how narrow some of our margins are. So that's probably one of the things why the sales have come off. Sustainability claims. Most of these products tell you what they are not. We're not meat, we're not milk. We don't kill animals. We don't use all the land. We don't use all the water. They don't tell you what they are. So what are you? It's really interesting marketing. We're not this. So at some stage, they're going to have to turn around and tell us what they are. And, you know, they're going to get better with products. They're going to get better taste and texture, and price is another issue. They're generally about 2-fold to 3-fold higher than the products they're competing with. That's an issue in the marketplace, but they're coming down. And in some products, the V2 plant-based burger we see in Australia, it's actually on price parity today. But you're going to have to demonstrate your sustainability claims. We've actually seen the first prosecutions in the UK where people made claims about sustainability that they could not back up. And we're also seeing, you know, I think they think that the animal industry stands still. But we're already seeing the first branded, you know, sustainable animal products, and we'll see more of these. Interesting, with all that's happening in the market, plant-based foods or plant-based meats have 1.4% of the US meat market. It's pretty small. So there's a lot of potential, and that's why, you know, they had these great growth rates, because when you come off a low base, you generally have a good growth rate. All right. This is what got me into this field. So this is a report in 2019 by a group called Rethink X. I don't know if you call them futurists or whatever, but generally they get to make statements about what's going to happen, and they don't necessarily have to be accountable for them. So their statements, it was essentially, and you can read it, was that the meat and the dairy industry would collapse because of cellular technology. So cellular agriculture was going to sweep through, and it was going to replace it, and we're all going to be out of business by 2030. And this technology is going to take over. So this was their report. It's got a lot of press, particularly people like the Good Food Institute, you know, played it up. But when you looked into it, it didn't have a lot of substance in it. It made a lot of assumptions that really didn't seem to hold up. So I'm going to unpick some of that. So the two big technologies they're really backing these statements around are cell-based meat and precision fermentation. Cell-based meat. So this is what it looks like. Okay. So we're not talking about a steak. That's the first thing to make. It's not a steak. It's sausages, it's burgers, it's meatballs. Okay. It's commodity. Let's look at what it means. For those of you who haven't seen this before, where is this gone? Ah, there it is. Okay, so what we start off with is we take a biopsy from an animal. or we could take bone marrow. It depends on what you want. If you want embryonic stem cells or you want muscle cells, there's a fair bit of work to actually then turn that into a stable cell line. So you're not going to grow primary cells all the way through it. So essentially you turn it into a cell line. You make sure it doesn't have any adventitious agents in it, any viruses, etc. And you grow it up. Eventually you get it so you can grow it in large fermentation. At the moment in the human health field, large in cell-based is about 20,000 litres. Some of the groups here are already commissioning vessels at 250,000 litres. Now, to be honest, it's just stupid because no one's ever grown cells to that. So it's probably virtual signaling for the next capital raise, to be honest, rather than good science. You generally scale up tenfold. So if I've got a 2,000 litre vessel I grow in at the end, I start with 2 litre vessel. And when that cells grow up to confluence, I move that to 20 litres. And I use that 20 litres to seed my 2,000 litre. So it actually takes time as well. So generally that timing could be anywhere from 60 to 90 days of continuous sterile culture to get those cells up to that scale. It takes a lot of nutrients, and we'll talk about that. The other piece of the story that they like to talk about is at the end, particularly if they've got muscle cells, they'll differentiate those and they'll get muscle fibers. So the answer is we're making real meat. Most of the groups aren't actually doing that. They stop at a cell slurry, because one of the problems you get into when you create fibers is you can no longer pump out of your tank. So I got a 20,000 litre tank and I've got all these fibers. How do I get the stuff out there? So most of them are using actually cell slurries. And as I said, you produce burgers, sausages. Generally, you blend them with some sort of plant-based product. So the only product on the market in Singapore, this is a chicken product. It's a 70-30 blend. Some of these are some of the key players. The Good Food Institute, one of my favorite people to debate on LinkedIn. They're the lobby group to this. There's something over 80 companies in the cell-based meat space and growing. It's probably 100 or so now. They put out some of the early reports that I'll refer to, pumping up this industry or this opportunity. Upside Foods used to be Memphis Meats. You know, they've got a facility. It can produce about 400 kilograms of meat per year. They talk about that as scale. But actually think about how many dressed carcasses is that. It's really not a lot. So we wouldn't call that scale. We'd probably call that a backyard butchering operation. But that's on a scale. So they're going to have to go a lot better. And again, you can see some of the raises there. Professor Post, who did the first one, the first burger, 2013, that was. I think it cost about $300,000 to produce that first original cell-based burger. Yeah, so that's probably enough about some of the players. So what are some of the challenges? And I'll go through each of these. So the biology of the mammalian cells, really interesting. Some people actually forget that this is biology, not chemistry. It's not engineering, although there's a fair bit of engineering in making those big fermentation tanks. So the media, cost of media, capital costs. Capital costs are a really interesting area. Sterile, this has to be run as a sterile culture. And we have a lot of debate about that because in the pharmaceutical industry, we know that. And a lot of the systems we use are about keeping it sterile. So consumer perceptions, regulatory, environmental. And again, these are their own figures, that the cost of manufacture has to come down over 1,000-fold to actually get anywhere close to the commodity meat products they're talking about. So let's take the first one. So mammalian cells are not easy to grow. They're rather fastidious. They're rather slow to grow. So your bacteria and your yeast, doubling about, every 60 minutes or so. These are 24 hours or more. So if you just think of it, that's one of the problems about it getting a contaminant. Think of how many times 2 I get in 24 hours, while this cell just doubles once. So if anything, any bacteria or yeast get in there, they overgrow the culture really quickly. So that's, you got to keep extraneous agents out of there. They require amino acid sources. They also require a lot of growth factors. tissue growth factor, fibroblast growth factor. And these aren't cheap, as we'll go into. Scaling, we actually have to scale up to large fermenters. As I said, most of the product in Singapore comes out of a 5-litre fermentator because they only produce 1,000 kilograms of the product in a year. So if we're actually going to get up and get near meat, they're going to have to scale up a long way. And as I said, the culture is going to run for quite a while. The gains we made in the product in the pharmaceutical industry. So when we first started, the biggest product we make ourselves is monoclonal antibodies. 5 or 6 of the major drugs in the world are monoclonal antibodies. So we've been at this for a while. We know how to do it, but it's not cheap. And we got a lot of our gains by manipulating the cells that produce the monoclonal antibody. You're probably not going to be able to do this. Some people are talking about it. There's some people are talking about we'll immortalize our cell line. What's an immortalized cell line? It's a tumor cell. So I'm not sure you want to go out and say, here's, how do you like my tumor burger? Probably not a good selling point. So they're not going to be able to use some of the tricks that we've done to really genetically manipulate the cells, because you're actually going to eat the cell. With monoclonal antibodies, all we want is the cells to produce the monoclonals, we harvest that. We don't eat the cells. But now you're going to eat these cells. So that's going to be a problem. As I said, they grow slowly. And the other one, really popular one, is people just keep telling me, it's not a problem because everything reduces in costs. Moore's law. People talk about Moore's law, transistor costs, everything comes down. Not a problem. Here's Moore's law as it relates to the cost of a genome sequence. So the Hugo project, when we first had the human genome sequence, it was, I think, $10 million for that sequence. You can now get a genome sequence under $1,000. But it's actually not a biological process. It's actually an engineering process. Biology doesn't apply to Moore's law. It's never been applied to Moore's law. It has lots of feedback systems. Cells won't grow of a certain density. They're fussy. They like nutrients. They don't like sitting in their own waste. So after a while, if you don't keep changing that media, they stop growing. So I love it when people tell me, you just don't understand Moore's law applied. Well, sorry, tell me a biological system that Moore's law is ever applied to. Cost of the media. So they got a company, CE Delft, to do a report. So they got all the people, the 10 biggest companies in this to provide their data, and Delft then confidentially looked at it and said, where are we on cost? And they said, look, you need to actually decrease costs 100 to 10,000 fold. Now, it depended on the scenario they ran. They then ran a whole lot of scenarios about how you might get that cost down. The trouble is there's scenarios, just like the Rethink X report. Some of them will pan out and some of them won't. One of the scenarios is we won't need growth factors. That's an interesting biology because that's one of the principles of this. We need growth factors. Someone tell you about, we'll just get cheap amino acid sources. I can tell you one of the problems in fermentation when you have cheap sources of amino acids is you get variability in manufacture. Manufacturers hate that. They'll take a lower yield as long as it's consistent, but they don't want the yields varying tenfold from one batch to another. You can't schedule your manufacture because most of the product, you make product to match orders. So if you've got an order to fill and suddenly you get a bad batch of media or bad batch of amino acids. And this happens, when I was at CSL, we pre-screened all of the batches of base material to make sure that when we put them into a large-scale fermentation, they didn't fail. The recombinant proteins, yes, maybe about $400 per gram, but some of them all cost $1 million per gram. So there's a lot of price got to come down if we're going to match in the end. And if we're going to match sort of ground beef, we're talking $2, $3 per kilogram for the final product. The volume of the media is really interesting. So GFI put out a report early on and said it's all about the cost of the media, and media is 80% of your cost of manufacture. Now, I quickly called up a few people I knew who ran manufacturing facilities in Biotechnology and said, what's media as your component of cost? about 20%, if that. Depreciation on capital, quality control, energy. So again, very interesting when you get a group to go out, promote this, and they get the fundamentals of manufacturing wrong. It's 20%, not 80%. Capital cost of the facility, again, Delft did a report and said, look, a large-scale facility will be around about 450 million US. But they didn't have all the manufacturing. So they actually said that's an underestimate. So our estimate is probably closest to 600 million US. And then calculate the depreciation on an annual basis that'll have to go into your cost of your goods. And you've also got to convince someone to actually put up that $600 million in the first place. A lot of stainless steel, a lot of energy. They didn't have downstream processing, formulation, QC or packaging in there. The standard manufacture is one that we debate. So they say, look, we won't need that over-engineered stuff that you pharmaceutical people do. Most of that is to stop contaminating your vessel. So we have positive pressure in the room. So when you open a door, air flows out. Because when we open a door here, air flows in, and that brings fungal spores. So leave a piece of bread out on your counter at home and see what happens over a few days. You know, so you have to have those sort of positive pressures. You have to have people in full PPE. These are not cheap staff. These are highly skilled staff. You don't need a lot of them because a lot of this is automated. Energy costs. You're running these fermenters at body temperatures, so 38 degrees Celsius. And then you think about the heat that comes off that vessel, that stainless steel vessel. So you actually have to then air condition the room to actually manage that heat. These are energy intensive processes. And a report out of Oxford said, if you don't actually use totally renewable energy sources, they actually won't be any more sustainable than what we currently do with an animal on the ground. So that's an interesting one on sustainability. And I talked about scaling, you know, as I said, you know, just comment about 250,000 litre vessels. You know, I find it staggering. I've asked around, you know, with some of the other companies, and they also find it quite surprising. The other reason why you wouldn't do this is from a manufacturing point of view. If I'm going to do 250,000 litres and the vessel goes down, gets contaminated or something goes wrong, I've got all these customers waiting. I put everything in one batch. So it's why you don't do it from a manufacturer. It's just too high risk. You're better off running a series of 20,000 litre vessels to manage your risk. So it doesn't actually make any sense from a manufacturing point of view. This is what a modern facility looks like if people haven't seen them. This is just the top of these tanks. These are 20,000 litre tanks. These will be over 3 stories, so get an idea of the sort of facility. So we only need to access the top. That's where all our probes are. Then we've got a floor, which is the body of the vessel, and then we've got a floor below that is where all the offtake occurs. So these are quite sophisticated buildings, and you can see the sort of gear that people wear. And that gear is not to protect them, it's protect what's in those vessels. So maintaining a sterile environment is a really big issue. We filter all the air, have to filter all the air, just like on your aeroplane. All the water has to be sterilized. So just think about that. I've got a 250,000 litre fermenter that I'm going to fill up. I've actually got to have 250,000 vessel holding water, which I then turn to add and make media to pump it into it. So you've actually got the knock-on effect, because I've got to actually have made that media up and sterilize it before I can put it in and add my cells to it. All incoming goods. You know, you have to quality control those. Keeping it sterile is the major job. It's why we have so much biosecurity in these facilities. It's interesting about the final product. So it'll be sterile while you culture it, but at the end, once you harvest, it won't be sterile. So it'll just be like a meat product as well. So again, what's going to be the shelf life of the product? Because a liquid product, generally, you know, unless you freeze them. I mean, why do we freeze meat? Because we get great shelf life out of it. Generally with cells, if you freeze them, they pop like a balloon. So you actually have to, one of the reasons to add things like plant-based materials is to actually avoid the cells just popping. And one of my favorite comments was a young student, you know, sterility, it's like pregnancy. You can't be a little bit sterile. You know? So it can't be, you know, it's, you know, it's generally pretty, we're 90%. No, you can't be. It's either sterile or it's not sterile. Nature of consumer goods. Have I run out of time? Oh, okay. So again, a lot of things on consumer goods, taste, minerals. You're going to have to remember, you're just growing cells. You're going to have vitamins. You're going to have minerals. It's not a prime steak, as I said. This is a 3D steak. This is cells printed as a 3D steak. When you cut into it, it doesn't quite look like a steak. And I'm not sure even that looks particularly appetizing, but you can do it. But imagine, how do you scale up 3D printing? How do you scale up? I'm going to print each individual steak. So it's interesting. You're adding cost. This is another company. This is layers. So they're printing a layer of muscle and then a layer of fat to make, you know, what they call is a really delicious product. So you can do it. But again, cost. Regulatory in the US, you've got FDA and USDA. Worst possible scenario you can ever have is 2 individual regulatory agents regulating you. Have you ever been in front of these people? They generally don't agree on too many things. In Europe, they don't generally will accept the recombinant proteins. That's going to be an issue. Labeling is still a debate. Taste, nutritional value, you know, cost. These are really significant issues. Let's talk about precision fermentation just very quickly. Why that? Because you're going to actually need precision fermentation to make the growth factors. What we're doing here is taking not a cells, but taking the DNA for the protein we want, putting it generally in a yeast. You can use bacterial yeast, but generally we do it in yeast. And then having that yeast produce our protein. That's actually the easy bit. It's the downstream processing. It's getting your protein out and at a purity. About 60% of the costs are in that protein purification piece of the action. This is a recent review I wrote, just lists some of the products that are actually on the market today. So this isn't new technology. Chymosin's been around for a long time in cheese making, but we're seeing a whole range of people. About 60% of the interest in this technology is in the dairy space, quite interestingly. And you can see, so, and more products are coming to the market. It's not got the same cost challenges that cell-based meat has, but it's still got some challenges and it's still got to be done at scale. So generally a scale facility of this is something greater than 100,000 litres in a vessel is the sort of scale that you need. The famous Impossible Burger, recombinant heme, gives it the smell and the taste of meat when it's cooked. This is the famous ingredient of the Impossible Burger, but because the Europeans won't allow recombinant heme, it can't come into Europe. So they are bringing the burger in, but they have to actually take out the recombinant. So they have to take out their secret sauce to be able to bring that product into Europe. So you can see how you can use these sort of proteins. This is one of my favorite ones I've seen recently. People say, oh, that's okay. We'll make these really cheap growth factors because we'll make them in plants. What's wrong with this story? What plant are they making it in? Tobacco. I just wouldn't have chosen tobacco. I'm just not sure how I sell that. You can do it, but why would you choose tobacco? Very interesting. The problem with this is, again, the downstream processing. It's even harder. So Dow Chemicals actually licensed a plant-based vaccine a couple of decades, built a factory, never launched the product because it was just too costly to extract the protein out of the plant matrix. So, yeah, I wish them luck. Regulatory, as I said, chymosin's been around for a long time. The products that are out there, the FDA, USDA call them generally recognized as safe because you are making the same protein that we would have in humans. So there's nothing wrong. You know, this is GMO technology. There's nothing wrong with that, but they won't use the term GMO because people don't like that term. So it's precision fermentation. Beta-lactoglobin, so again, that's being made and put into dairy products. I find this one interesting because it's a single dairy protein. Remember, there are about 6 key dairy proteins, and then there's a whole lot of others. So they make products with a single protein, and then they say, this is dairy. I use the analogy, it's like I'm going to paint a copy of the Mona Lisa, but I'm just going to use one color, because why waste the energy on all those other colors? It'll be as good as the original. I just need one color. Sorry, a one protein is not equivalent to a dairy. So there are groups, you know, Eden Brew and Algae, that are going to try to make milk with the 6 key proteins. Bit of a challenge, but I think they'll probably do it. The cost of goods will be the issue. And again, the US has also got a bioengineering label. So some people are going to, you know, the anti-GMO critics are probably going to have a field day with that. So to sum up, what do I think is going to happen? So the first one is, I think in the end, we have to talk about all of our food as nutritional value to environmental footprint. Nutrition won't just be single components. And environmental footprint won't be just greenhouse gas, be biodiversity, water use, land use. Animal-based products will always look better expressed in this way, because our nutritional value, as you've heard yesterday, looks always better. The quality of the protein, energy, the nutrient density. So it will always look better if we express it in this way. From a point of view of cell-based meats or precision fermentation products, I think they'll service niche markets and high value. Niche markets, but at high value. That doesn't sound like Africa to me. So if we go back to what the problem they're trying to solve, I don't think they're actually going to solve that problem. And scale will be it. As I said, the tech actually works. It's the scale, it's the cost that's going to be the challenge. But as a scientist, never say never. Thank you.